G'day guys, we've got an exam question today which is asking us to integrate the rational function 3x plus 7 over x squared plus 3x minus 4. Now on the surface of it guys, it looks like a relatively complicated integral for us to do, but what I'm going to show in this video is that by using a method called integration by parts, we can break down this rational function into smaller, simpler components, and then we can just apply the fact that we know that the integral of 1 over x dx is the natural logarithm of the absolute value of x plus c. So to do this method, what we have to do is we have to first break the denominator into its factors. So what we're going to do first is we're going to factorize this x squared plus 3x minus 4. So to start with, I'm going to write down x squared plus 3x take 4. And if I factorize that, guys, hopefully you guys will be aware that this is just going to be x plus 4 times x take 1. Cool. So what I'm going to do with this now, guys, is I'm going to use this to break down this rational function here. So what I'm going to do is I'm going to have 3x plus 7 over x squared plus 3x take 4 is going to be equal to a divided by x plus 4 plus b over x take 1. Now obviously guys, you don't have to worry about the brackets on these denominators here, but I just do it to separate it. It makes it less likely that I'm going to make a mistake, I guess. So from here guys, what I'm going to do is I'm going to put these over the same base. So I'm going to combine them back into one fraction. So to do that, I have to multiply the x plus 4 by x take 1. So I'm going to be left with a outside of x take 1 plus, and b, what I'm going to have is I'm going to multiply that by x plus 4, all divided by x plus 4, x take 1. Cool. So what I'm going to do now, guys, is I'm going to multiply out my brackets in my numerator and collect my like terms. I'm going to have ax plus bx to start with, and I'm also going to have minus a plus 4b on x plus 4, x take 1. Cool. So what you can see here, guys, is this ax plus bx has to equal 3x to make these two an equivalent fraction. So over here, I'm going to say that ax plus bx is going to have to equal 3x, and 4b take a is going to have to equal 7. Okay, so from here, guys, I can quite easily see the first equation. I can get rid of the x's from both sides, and I'm left with a plus b is going to be equal to 3. And with this second one, I'm going to rearrange it to make it a is equal to 4b take 7. Cool, so we've got two unknowns with two equations here, guys. We can do a little bit of, we can solve these simultaneously using the substitution method, where I'm going to substitute a in for a in the first equation. 4b takes 7 plus b equals 3. So 5b is going to equal 10, and b is going to equal 2. So from here, guys, because I know that a plus b is 3 and b has to equal 2, quite easy to understand, hopefully, that a is equal to 1. So what I'm going to do is going to take these two values and I'm going to stick them in this equation here. And so I have the integral of a is going to be 1 over x plus 4 plus 2 over x take 1 dx. Now this is quite simple to do because I can break this down. I can say, well, this is going to be equal to the integral of 1 over x plus 4 dx plus 2 times the integral of 1 over x take 1 dx. And from here, guys, we're going to use this relationship here. So we're going to get the natural log of the absolute value of x plus 4 plus 2 times the natural log of the absolute value of x take 1 plus c. Cool. Okay, guys, so now we've got our solution down here. What I thought I'd do is I'd give you a quick recap of how we got there. So first of all, I saw this question and realized I couldn't just find the integral of it straight away. In an exam, this should take you about a second or two. After I figured this out, I then realized that I needed to break it up into smaller, simpler, but equivalent fractions. So to start with, I factorized my denominator so I could split the large rational function into two smaller fractions. and then figure out using simultaneous equations what the equivalent numerators would have to be on each of these smaller fractions in order to be an equivalent fraction to the larger original one. After I did that, it was pretty simple. All I had to do then was take the integral of the smaller fractions, which you can do individually, and out comes the solution. So if you had any problems with this video or the way I explained it, guys, please don't hesitate to leave them in the comments section below. Also, if you have any problems with any of your maths that you've run into, also leave them in the comment section below, and I'd be happy to try and solve those problems in a video in the future. So guys, questions like this in exams that are worth 3 marks, you need to be able to do them relatively fast. So practice, practice, practice. This question here, I would probably not use all this working at it in an exam simply because I need to get it done fast so I can move on to more complicated problems. In an exam, well, in this particular exam that this question is taken from, this was one of, I would say, in terms of 0 to 10, 10 being the hardest problem in the exam and 0 being writing your name on the front cover, this was probably up near a 5 or 6. So not too simple, but obviously not the hardest problem in the exam. So keep practicing them, guys. Eventually a light bulb moment will occur and you'll be able to solve them no problem every single try. But again, in an exam, it's about trying to keep those silly mistakes to a minimum. So keep practicing, practicing, practicing. But most of all, guys, keep remembering to enjoy your maths, subscribe to my channel, give the video a thumbs up, and I'll see you again next time.